Here the generation of these subtropical gyres is attempted to be explained again. Okay, so you have a very simplified description of the surface winds. It just ignores continents of the ocean, limitations of the horizontal extent of oceans, and just very simplified wind fields, westerlies and trade winds essentially, and shows you the Ekman transports. Okay, the Ekman transports. And you can see that there are zones where you have a convergence and zones where you have a divergence of these Ekman transports. So if you now go one step further, you come to the next slide. Okay, the next slide, where you actually look at what does the convergence do. Okay, what does the convergence do in terms of creating a high pressure or a low pressure center? Okay, so you get pressure gradients. Okay, high pressure gradients between the high and the low, and then you can imagine what happens under the influence of the Coriolis force. Sorry. So you want to move water from high to low pressure. This is shown here. Let's see where the mouse is. Can you see where the mouse is? I'm just here, northern hemisphere. You want to move water from high to low pressure, but the Coriolis force kicks in and moves water from west to east instead, along lines of constant pressure. So this is the geostrophic flow that you get from left to right. Near the equator, you get a flow from right to left. And in the southern hemisphere, you can do the similar situation. Okay, so you can work out that on this very simplified example of having an Earth fully covered by oceans and having these zonal wind patterns, you essentially get also zonal currents in the ocean. So either from east to west or from west to east. Okay, but now the real world looks different and you get some additional features. And we talk about that, okay?